In the last video, we talked about what a nonlinear system is and how to solve a nonlinear system of a quadratic and a line using the graphing method. So first graphing the line, then graphing the quadratic and identifying where they cross. What we're going to do in this video is we're going to focus on two algebraic methods for solving. These are the same two methods that we used when we were solving linear systems back in the linear chapters. So first we're going to talk about substitution. How do we solve a nonlinear equation or a nonlinear system using substitution? The very first thing we're going to do is we're going to solve for one individual variable. And in this case, if we're talking about a quadratic and a line, that's always going to be 1. We need to have y equals stuff. Everything needs to be on the other side. Fortunately, sometimes that's already done for us. So sometimes we get to skip on to step 2. Otherwise, we need to isolate y. Then we're going to substitute whatever this stuff is that we just found y is equal to into the other equation for y. So we should then have one equation that has one variable, x. We will then solve for that variable x, and once we find x, we will plug that back in to find y, and we need to make sure we write our final answer as one ordered pair or two ordered pairs, or as no real solution if that is the case. So let's go ahead and look at some examples here. In example number 1, I have y equals this already. So y is already isolated, so I can substitute that in for y in my second equation. So x squared plus 4x plus 3 is going to equal what y equals down here, x plus 3. Then I'm going to get everything on the same side. So I'm going to subtract x and subtract 3 on both sides of the equation. So x squared, 4x minus x is 3x plus 3x. Negative 3 and positive 3 is 0. So x squared plus 3x equals 0. Well, now we have a quadratic equation that we can solve. We can factor, we can use the quadratic formula, we could complete the square. This problem actually has a GCF that we can factor out, and that GCF is x. And if we factor out that GCF, that leaves us with a pretty simple equation to solve. Either x is equal to 0 or x plus 3 is equal to 0, which gives us that x is equal to 0 or negative 3. Now, don't forget, our goal was not simply to find x, but to find the solutions, and the solutions are ordered pairs. So what we just did is we just figured out that one of our x values is negative 3 and the other x value is 0. What do we need to do now? I'm going to just create some more space here. We need to now find y. How do we find y? We plug it into either of the equations. This one looks simpler. If y equals x plus 3, then when x is negative 3, y equals negative 3 plus 3, which is 0. If y equals x plus 3, then when x is 0, y equals 0 plus 3, which is 3. And I have my two solutions. So we took what y was equal to, x squared plus 4x plus 3. We substituted that in for y in the second equation. So then we had one equation, this one right here, that no longer has any y's. We moved everything to the same side and we solved using any of the tools that we have learned earlier in this chapter to solve this quadratic equation. However, once we found our x values, we substituted those back into either equation. I chose the line because it required less math, and then we solved. Let's look at number 2. Okay, again, I have y equals, and what is y equal to? X squared minus x minus 5. I can substitute that in for y into this other equation. I'm going to come over here. X squared minus x minus 5 equals negative 3x plus 3. I'm going to move everything to the same side. So I'm going to add 3x to both sides, and I'm going to subtract 3 on both sides. That gets me here. This quadratic looks like it's going to factor. Let's see if I can factor this. What makes x squared x times x? What makes 8, 4, and 2? I want it to be negative 8, but positive 2. That works there. I'm going to set each of these equal to 0. So here x equals negative 4, and here x equals positive 2. X minus 2 equals 0. So if we add 2, x equals positive 2. So again, don't forget, we only have now found the x values of our solutions. To find the y values, we're going to use that. So find y. If x is -4, y equals, I'm going to use this equation, -3 times -4 plus 3. 12 plus 3 is 15. So -4, 15. If x equals 2, y equals -3 times 2 plus 3, which is -6 plus 3, which is -3. And we have our two solutions here. So I encourage you to pause the video and go ahead and work through number 3 on your own. If you get stuck after the substitution step, I'm going to recommend that you unpause and see the little trick that I use. But go ahead and try it on your own. All right. Step 1, substitute this in. -1/2 x minus 3 equals x squared. Step 2, get everything on the same side. So I'm going to add 1/2 x and add 3. Add 1/2 x and add 3. That's going to give me 0 equals x squared plus 1/2 x plus 3. Now, lots of things that you could do here to solve this quadratic, but I know that many of you are uncomfortable with fractions. Well, this is an equation, and back in the very first unit of algebra, we talked about how you can multiply something to eliminate fractions as long as you do it on both sides of the equation. So I'm going to multiply 2 everywhere. If I multiply 2 here, I still get 0. I get 2x squared, I get plus x, and I get plus 6 because I'm making sure that this 2 is multiplying to each individual term. So to give myself more space, I'm going to rewrite that over here. 2x squared plus x plus 6 equals 0. Now, when I first look at this, I'm not sure if it's going to factor. I can't think of things that multiply to be 12 that are going to add to be 1. It's not a great candidate for complete the square since I have a 2 in front as my a value. So I'm going to jump into the quadratic formula. So x equals, the opposite of b is -1 plus or minus the square root of b squared. Well, b is 1, 1 squared is still 1. Minus 4 times a is 2 times c is 6 all over 2a. So 2 times 2. So x equals -1 plus or minus the square root of 1 minus 4 times 2 times 16, or 8 times 16, which is going to be 1 minus 128 over 4. Well, this is going to equal -1 plus or minus the square root of -127 over 4. And since there is a negative number here, we have a negative number inside a square root. This is going to be no real solution. So for number 3, which is this system over here, this quadratic and this line never cross. So there's the substitution method. We're going to next talk about the elimination method, and I'm going to tell you that the only difference between these two methods with nonlinear systems is typically the very first step. So instead of substituting one equation into the other, what we're going to do is we're actually going to multiply so that we can eliminate y. This should say y. We're going to multiply so that we can eliminate y. Then we're going to solve for x, and then we're going to complete the same steps that we have already been doing. So let's look at some examples. Y equals x minus 5, and y equals x squared plus x minus 6. So thinking back to when we did linear systems, we said, what could I multiply one of these two equations by so that when I add them together, I get 0? So what I could do to eliminate y, remember we want to get rid of y first, is I could multiply this equation by -1, because now if I rewrite this here, my y and my negative y are going to become 0, and that's my goal, is to eliminate y. So if I multiply x by -1, I get -x. -5 times -1, I get +5. And now I can take these two equations and add them together. Y and -y is 0. X squared plus nothing is x squared. X minus x is 0. -6 plus 5 is -1. So you could solve this by factoring. I'm actually going to use the square root method. Since there's no bx term, I'm going to add 1 to both sides, and then I'm going to square root. So x is plus or minus 1. Again, I just found the x values. I haven't yet found the y values. Let's do that. Find y. If x equals -1, I'm going to use the first equation. Y equals -1 minus 5, which is -6. if x equals 1, y equals 1 minus 5, which is negative 4. So again, the real difference is just what we did first in order to eliminate the variable. We still eliminated the variable using the substitution method. We just did it by substituting one equation into the other. Now we're multiplying one equation by something so that we can add them together and eliminate the variable in a similar way. Okay, I'm going to rewrite these two equations on top of each other so that it's a little easier to see what's going on here. So y equals x squared, I'm going to write my quadratic first, minus 4x plus 4, and x plus y equals 4. And I'm going to make sure that all my variables are lined up, my y's are lined up, my constants are lined up, my equal signs are lined up. So I'm asking myself, what could I do to one equation to eliminate y? Well, I could take this second equation and I could multiply it by negative 1. So I'm going to rewrite my first equation, y equals x squared minus 4x plus 4. After I multiply by negative 1, negative x minus y equals negative 4. And then I can add those two equations together. Nothing plus negative x is negative x. Y plus y is 0. That was our goal, to eliminate y. X squared minus 4x, 4 plus negative 4 is 0. Now I can solve. So add x to both sides, x squared minus 3x. And this I can solve by factoring. So this is going to give me that x equals 0 or positive 3. So I have the x values of my solutions. To find the y values, I can plug them in. X plus y equals 4. If x is 0, then y is 4. X plus y equals 4. If x is 3, then y is 1. And I have my two solutions. Now this problem, both of these problems could have just as easily been solved using substitution. I could have taken this expression and plugged it in for y into this equation and solved and gotten the exact same answer. So this is really a personal preference. And how is the problem set up? Sometimes it's honestly the same amount of steps to solve whether you use substitution or elimination, and sometimes it could be slightly more or slightly less. But the goal is that you could use either method, and that you can use the method that you feel more comfortable with to accurately solve a nonlinear system. So to recap what we covered in this section, our goal was, how do we solve a nonlinear system? We talked about how to do that by substitution, where we solve for a variable, substitute that in, solve for x, find our y values after we find our x values, and write our final answers as ordered pairs. And then we talked about elimination, where the only difference was the first step. Instead of plugging an equation into another, we actually multiply an equation by something so that we can eliminate y, and then work through that same process. Our goal in either case is to find the solutions, find the points where this quadratic and line intersect. If that happens, it can happen 0 times, like on number 2. It can happen once, or it can happen twice. So write down any questions that you have, and I look forward to supporting you on this. Thanks for listening.